So let's continue with the sensitivity analysis report that comes out from our linear programming problems. So any change in the right-hand side value of a binding constraint will change the optimal solution. So if I go up or down on the right-hand side, then it's going to change if it's a binding constraint because it's the thing that's stopping me from doing stuff, right? It's where the corner point, it's the where the corner point that solves the thing is. It's going to change. So we also have the flip side of that, which is the optimal solution is not affected by a change in the right-hand side value for non-binding constraints, given that the change is less than the slack or surplus. If it's beyond that slack or surplus, then all bets are off. And then we often also want to answer, all else equal, how much would the optimal profit change if the right-hand side is changed by a single unit? So in our example, if we had 1 more pound of plastic, how much more money could I make? Or vice versa, if I had 1 less pound of plastic, how much would my profit be hurt? And then we also are interested in, for that amount of money that is going to go increased if I increase my right hand side for a less than or equal to constraint, how many more units of how many more pounds is that number valid for? Right, so those are the two things we're going to be looking at. So if we have a less than or equal to constraint and the right hand side value is increased, the constraint becomes less restrictive. We've relaxed it. So instead of 1,200 pounds of plastic, if I have 1,201, in theory I should be able to make more money because I've got more resource. Right? So I've relaxed it for a less than or equal to constraint. If I shrink it to 1199, then I've become more restrictive, and so the objective function can only worsen or stay the same. So in order to answer the question about how much it's going to change the profit, our optimal objective function value, we are going to look at the shadow price. So the shadow price of a constraint is the change in the value of the objective function resulting from a 1 unit change in the right hand side value of that constraint. And there are two ways to interpret it. One is with sunk cost, the other is with included cost. I tend to think of it in terms of sunk cost, but you can think of it however you want. So I tend to think of it as the maximum a firm is willing to pay for 1 additional unit of the resource. So in addition to the shadow price, the amount that we're willing to pay for an additional unit of the resource, then we want to know what range that number is valid for. That's called the range of feasibility. So within this range, the binding constraints will determine the optimal solution will remain the same. So in our case, we had labor and plastic as our binding constraints. So if we change just one of the right-hand sides within that range of feasibility, those two constraints will still be the ones that's stopping us. That's where the corner point is going to be. But the coordinates of that solution point are going to change because I've changed the slope of the line by changing the right-hand side. So obviously the objective function will also change. So in Excel, in our output here, we're focusing down on the bottom part now, the constraints, and we see shadow price for plastic in pounds is 3.4. All right, for labor 0.4, and we see that the $3.40 in profit that I could make if I had 1 additional unit of 1 additional pound of plastic. At $3.40 is good for another 150 units that we could increase it. The 40 cents for each minute of labor is good for another 400 minutes. So a lot of times what we might also want to do is think about which one of these would I prefer to put my resources towards first. So remember, all of this interpretation from the sensitivity report is that we're only doing a single thing changed at a time. So let's go do this. Let's go back to our spreadsheet and let's add 1 additional unit, 1 pound of plastic. Our profit should go up by $3.40. So let's see if I can find it. Alright, so here's our shadow prices, right? Here's our allowable increases and decreases. So let me copy this one. Put it at the end. And I'm going to change this to 1201. And so I think it's going to go up to $5,043.40 when I solve this. So get rid of this and then go to Data Solver, and everything should be set up. Click Solve and click OK. Yes, my profit went up by $3.40. Notice now I'm doing fractions of stuff. That's okay. We're in linear programming. We can do that. So that's good. All right. Now it could only go up to 1350, and then after that we can't guarantee anything. All right. So, or if we changed two right-hand sides, then we would want to resolve it also. So that's shadow prices and the range of feasibility.